Recording in progress.
Are you ready, Sai?
I can see actually.
Okay.
We are waiting for Sai or
Yeah, he said.
Oh, sorry. I'm good now. I'm good now. I
Oh,
didn't
okay.
know. Yeah,
Okay.
yeah, yeah.
yeah.
Sorry.
No worries. So my question. So what is traveling inside a fiber optic cable?
A light.
Light only.
Very okay, right. Perfect. So light is traveling in a fiber optic cable. The light source can be LED or a laser light.
Okay.
Okay. So now I have a question. So for example, you have a glass of water and you put a stick on it.
Yeah.
If you look at from your eyes, how it looks like?
Bent.
Uh,
Reflection.
Reflected. So it is
Yeah.
actually looking like this one. Mm,
Bent somewhat
right. Why it is bent?
because of light.
It,
Is
it,
in the
it
other direction, I
looks
think.
like that. Okay. Instead of looking like it.
Yeah.
Okay. Why it is that?
It's because of light falling on the water. Maybe
Refractive index.
reflect. Yeah.
Very good. So what actually happen is here the material is air. Okay. Here
Yeah.
the material is water.
Water.
So both when light is traveling from one medium to another medium, it started refracting towards inwards or towards outwards. Will you agree that either inward or outward, depending upon the material or medium? So what actually causing this is this parameter is called the refractive index.
Hmm.
Okay, so refractive index is nothing but it is the ratio of speed of light divided by speed of light in any medium. Okay, so in general, in air, how light travels, that is speed is 3 into 10 power 8 meter per second. If it is traveling in a water, that speed is different. If it is traveling in a glass, the speed is different. So for example, I want to find out the refractive index of glass means the formula changes like this: speed of light in air divided by speed of light in
Water.
glass.
Yes. Okay.
Glass. I'm finding it. If it is for water, you need to keep changing it for glass, strike out glass, and you find it out for water. So
Hmm.
the general rule of thumb is because the refractive index of each medium is different. That is why when light is traveling from one medium to another medium, it is refracted, maybe internally or externally in a direction. So that is the rule of thumb. Will you all agree that?
Yes.
Okay, we'll not go deep into that because that will become a physics class.
Yeah.
So in general, for glass, mm, mm, okay. In general, the refractive index of glass equal to 1.33. That is mentioned as in the sigma. Okay. So glass refractive index mean 1.33 means what is it?
Class is what
3 into 10 power 8
power of 8.
meter per
divided by
second divided
Mm,
by x value. Okay, whatever it is. So x equal to 3 into 10 power 8 divided by 1.33. And now you get it close to 2 point something, it will come 10 power 8 meter per second.
mm.
Okay, so that is the agenda. So refractive index, you remember it. Now the understanding is whenever light is traveling from one refractive index to another refractive index medium, the light will either reflected, refracted in whatever direction depending upon the refractive index of the medium.
Okay.
Now, using that, they started playing with the fiber optics. What if you look at the fiber optic cable, it looks actually like this. Okay, this inside is called as core. This is called as cladding.
Mm,
This is the structure of the fiber cable. So inside this part, the core is having high refractive index, Ri, and cladding is having a low refractive index. They designed a fiber like this. It can be a glass material. Um, it can be a glass material or sometimes plastic. But nowadays it is both glass only.
okay.
So why they have made is the core has a high refractive index. This is a so we are going to do something with the bending of the so something is refracted because there is two purposely we made the refractive index different. So the same fiber optic cable in a different angle, side angle. So this is the core, this is the cladding.
Mm,
Okay. So whenever a light is traveling in this direction, it goes here, it reaches the boundary because here refractive index is different, here refractive index is different. It is
mm,
getting reflected. Again, the same phenomena continues because whenever
mm,
it reaches the edges, it goes like this.
mm.
Got
Okay.
it, Soy?
yes.
This phenomenon is called total internal reflection. This is the fundamental physical thing. They made the light to travel like this in the modes. These part is called, these parts are called mode, modes of the fiber.
Okay.
Now, I have a question. This is one road. Only one bus can travel in this one. Consider a situation like India. This is another road. So now, what will happen both the case if driver is traveling here, traveling here, and
Hmm.
okay, you are driving the bus in this lane. How the driving behavior will change in both the scenarios?
In that multiple lanes you can travel in any lane, right? Here you can
Okay,
able to one lane. Based on the traffic, you will pick out the lane.
okay,
Decide
multiple lanes. Okay,
what
what else? This is single lane. What is the advantage, disadvantages, both the cases?
Bus cannot move in the single lane.
In
You
this
have
lane,
to follow the, yeah, you have to follow the same lane until the end.
it has to follow the same line until the end.
Yeah.
Uh,
But here you can change according if there is someone in front of you, you can change the lane and overtake them.
Forget about no one is there in the road. Only you are there in the road. So you took a road, travels in one single direction to reach the question. So here you are going like this. Ah, so now, who in this kind of scenarios, but who will reach first?
The single lane one because it was going, he's going straight.
Speed, no other option. Go to your forward, full speed. Here,
Hmm.
bit slow.
Yeah.
And what is the driving experience?
What driving
Uh,
experience
How you feel while driving here, here, which one you like it?
in single lane only.
Ah,
Multiple lane stakes, yeah, multiple lane.
uh,
You you have to reduce your speed sometimes,
mm,
and then you have to change lanes.
you have to change the line. If you have cruise control, you can put it on and you can even sleep in the single line. It will straight away reach the destination.
Yes.
So the same case in the fiber optic, same core and cladding. Now the same light, it is splitted into it. It reaches the destination in multiple paths. So, so same source, but it travels in multiple modes. This is called as multi-mode fiber.
Mm.
What is the only condition for single mode and multi-mode fiber? What decides it is single mode fiber or multi-mode fiber? Consider our road example.
Depends on the traffic, right? So I mean,
No,
the car.
no. I said road example. The only condition differentiate the single mode and multi-mode. No, width of the road. If you don't have the option, you will go straight, right?
Yes, 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 agree.
Sorry, why you were silent. See, you don't have a room here. Here you have a large space available. So you left and right, you are driving on your own,
yeah,
correct?
yeah.
So the width of the road is here. The same way here, the width of the core. The size of the
is
core is matter here.
less, right?
Yes, if it is very narrow, then it is single mode. It is in the form of 6.5 micrometers. If it is big enough, this is multi-mode. Multi-mode, and then it is 50 micrometer. The size is increasing. Got
Okay,
it?
but
Single is 0.
uh,
Single is what, 6.5 or 0.
6.5, very less. The size
Hmm.
is very less. The width
0.5.
of the road is very small.
Okay,
Here, the
okay.
width is quite big. 50
Okay.
meter.
so which one we are using now?
Very good.
Most
Which one you
efficient.
prefer?
I
Multi-mode.
prefer single.
Why, Harish, you said multi-mode? Why, Sai, you said single mode?
So what I think is like you can it is having the speed.
Ah,
The single line has speed.
ah,
So in the cladding we can put more single lines.
ah.
So that the data can be transferred.
Core. Light travels in core only, not in cladding. Why we use cladding is to make the light travel in the only in the core. That is the purpose of the cladding. Oh, okay.
Can you show the picture of like how it will
Fiber.
be like
Yeah, I
yeah
will show
fiber.
that. Yeah, I will show that. Don't worry. I will show that.
Okay. So cladding means nothing but the like on the
Out,
top of the
out of
wire.
it. Yes, it
Outside.
is like this. It like one big pipe, inside one big pipe, one more small pipe is there, inserted
Yeah.
inside.
Okay. Uh-huh. So can we put more pipes in that?
Yes, we will see that when we will see that in today's class. So, are we clear about single mode and fiber, multi-mode fiber?
Yes, yes.
Yeah, which is efficient. Very good.
Okay, which is efficient. Very good. The same case. Why, Harish, you said multi-mode?
So, for example, if it is a short range transmission, I would prefer, if it requires an high bandwidth, I would prefer a multi-node mode. So,
Okay.
I used to hear that in for example, in campus, college campus, if you are having a Wi-Fi network entirely throughout the campus,
Ah,
distance only, no, that it's not going to travel to long distances and all. So, in that way, I might use multi-node
okay.
mode.
Got it. Actually, yes. In this case, Sai, no doubt, performance-wise, the best one is single mode. No. Since the cost of the fiber and the electronics involved it is cheap compared to multi-mode. So the rule of thumb is inside a data center, inside a home, all these things we are using a multi-mode fiber. And for long distance, ultra long haul, those cases, we are using the single mode fiber. And another disadvantage in the multi-mode fiber is these rays. So whenever a light, okay, so if you look at the torch light, okay, the light goes like this. Will you agree that
Yes, yes.
it? What is
It
this?
expands. It expands.
Spreads or expands.
Expands. Yeah.
In scientific, we used to call it as dispersion in technical term. Dispersion. Okay. Dispersion. So, the broadening of the pulse, that is called as dispersion. Okay. So, you like this behavior?
Uh, which okay.
This broadening, what will happen eventually if you keep on broadening here?
You might not see at all.
So you don't want it.
Yeah.
So, another question. You have this people used to play with that. And you remember that in Chennai airport, there is a small hill. There is a small mountain in Chennai airport. Well, what happened? The people living there are like low class people only. So they used to what they do, they climb the mountain and the flight has to come on the whenever it comes on the reverse direction or forward direction, the people used to play the laser light towards the plane, so it disturbs the pilot a lot, actually. So why I want to say that same torchlight which we are using multiple AAA batteries, it doesn't if you show the torchlight, even a pilot doesn't see it, but the small LED light which we bought it for 25 rupees bothers the pilot. Why it is?
They lack the clarity because
Mm,
uh,
It don't have the dispersion.
okay,
The the fiber like the laser light
okay,
don't disperse.
no dispersion, okay, then
And also,
feel intensity.
yeah, intensity also it's a good thing
intensity
here.
is high because
Yeah.
you are focusing on it one particular direction only. So even if you use 4 AAA battery, here you are using a cell phone size, what is that cell battery? What is it? This battery is used to call a silver battery, which is in circular size. So this makes the light more intense, more, even if we don't require an extensive power supply, but still we can make it because of these things. We make the light travels like this, still it disperses, still, but after a distance only now. So second one is intensity. You are talking about intensity is nothing but you are doing something to the light source. Usually the light which travels in all the directions. This is called unpolarized light. I don't know why it is shuttling between here. I can't move this to here, so my hand touches. This is a one big blunder here in whiteboard. All other boards, it is there in the top. Okay, so here what we are doing is we are changing the direction of the light, either travel like this or vertical direction or in the horizontal direction. You got it? So in general, the light is traveling in almost all the direction, omnidirection. Here, in a polarized light, it travels only in two direction, horizontal or vertical. That is why those lights are very narrow. It reaches beyond what the torch lights can't able to reach it. That's why if you look at the Home Depot, if you will see the torch lights, they said polarized light. Now they raised it, light it as a polarized light. Got it? All good? Clear? So these are all the physics in the so so what are all the things we are going to remember here? Um,
Uh, I got. I have some doubt.
yes, sorry.
In multiple layer and
Ah,
multi mode and single mode.
ah.
Like, can you explain it? So,
Okay. What confuses you? Even I got confused when I'm in my early stage. What is confusing you in multi-mode?
so we use
This is
multi
single
mode
mode, this is
now.
multi-mode. Ah.
Yeah, yeah, we use multi mode now. Most single modes.
Okay.
That's
No, that only that is confusing, or
The
uh,
concept. Yeah.
the concept is confusing.
no concept. Concept I'm clear.
Ah,
So one light passes to one single lane, that is like a single mode,
correct.
but multiple lines passes through the multiple uh,
Correct.
fiber.
So which one is using? So now I am telling very clear, no doubt. We are slowly moving towards entirely on single mode. Why multi-mode means initially we started with the multi-mode and then they understood the concepts and they bringing down to single mode. Still multi-mode is used because the only factor is we don't want high power. Okay, in the internal communication. For example, if you are traveling from one city to another city, you need a full tank in your fuel tank. You need full gas. But if you are traveling inside your city, you don't need to fill your tank. The negative of loading the full tank is what? You are hit with the mileage because you are increasing the weight, you are hit with the mileage, correct?
Yeah.
So similarly, here in the multi-mode, single mode, what we are using it, in single mode, the power was preserved, the intensity is preserved, but high power eventually sometimes damage the receivers. Okay,
Okay.
so
In
that
the
is why
small.
we don't need high power in always looking. We don't. We want a little bit lower performance, lower cost. So that case you are using multimode fiber. If you
Okay.
look at in general, mostly commonly, I'm saying that single mode fibers looks like yellow color cables. Multimode cables
Mhm.
looks like in a light blue color cable. That
Okay.
is how they differentiate it. But
Okay.
looking at the eyes, you can't differentiate it. So this is the one common setup. The extreme cases, multimode fiber may be in orange color. That's it. Otherwise, they follow the same color pattern.
Okay.
Only thing is, we used first multimode was invented and then single mode. Multimode is cheaper compared to multimode. So and also in the local room to room communication, multimode is more than enough because of the cost people you are using it. Otherwise, this excellent superior performance comes from, as per the example, single mode fibers only.
Okay. So width is less, right? And single
Yes,
mode.
only thing is differentiating factor is if you road example. In even in some cases, you are bounded to travel in only one lane. You can go just like that straight lane. But if the road is big, you tend to move lane to lane, crossing here and there, and you will reach the destination little bit slower than the single lane, but that small changes matters in the internet, in the communication systems.
Okay.
Okay, so what are all the things we remembered it? One is
Refractive.
refractive index. Why we learned refractive index? Because if refractive index of the material changes, the what changes? The speed in which the light travels also changes now.
Change.
Then we
Mm.
saw core and cladding. What is core and what is cladding? And then we saw single mode and multi mode.
Hmm.
And what else we saw?
And the polarized, yeah.
Polarized, non-polarized light.
Okay.
Hello.
Hello,
Ah,
Surendran.
yeah,
Okay.
yeah. I'm referring my notes. Okay. Uh, no, one more we missed out here. Uh, and this is another one is the light source used is LED or laser. Shorter distance, we use LED. Longer distance, we use laser. Laser is costly, LED is cheaper. That is one thing. And core cladding materials also, we saw that glass. Glass and plastic. Okay. And then I forgot to tell this one. Okay, what it is called, this is one term. So if people tomorrow ask how light is traveling in a fiber, it is called total internal
Reflection.
phenomenon. What is the spelling of phenomenon? Okay, uh,
PHEOMENY.
right now. Okay, this is
Yeah.
the phenomenon. Okay, these are all the core things you need to remember it. Okay, good.
Total interest.
Total internal revenue. This is the fundamental thing. It is okay. So if I want, if this phenomenon has to happen, then what is the basic criteria for it? And so you need to send the light in one angle. This angle is called critical angle. Critical angle. If you send in the light in this angle, then only this phenomenon will happen, total internal reflection. So this is called as critical angle. Critical angle, how it looks like for same fiber, actually it looks like that, it like a funnel. You are inserting like a funnel here. In this area, if you send light anywhere, here it will be totally looking at. This area is called as numerical aperture. Got it? You understand this picture, right? It's like
Send
a
the light
yeah.
at
If
critical
you
angle.
if you pour the water inside this funnel, then only it will go inside this part. Similarly, if you send the light in this funnel, then only it will travel inside the core. We want the light to travel inside the core. Okay.
Mm,
So
mm,
critical angle. Now you got this one. If somebody asks how light travels in fiber, then you need to tell it's traveling in total internal reflection. If you send the light in a critical angle, then that angle, the light will be totally reflected inside this one. And this numerical aperture is nothing but this is the area in which you can send the light. The entire light will be captured inside the core. Perfect.
okay. Critical angle is you have to send the light in one angle only. No, it
Right,
is a
right, right.
multiple aperture. You can send it like it's like a vessel. You can send it
Uh,
through, and
the
then it,
area. So it is not like just one part, one angle. It is like a area. This is area. Till this critical angle, you can send the light in this one.
mm,
Anyway, so this area is called as the numerical aperture.
mm,
So, ah,
okay, okay, I understood.
now, so, okay. So, what are all the losses inside the fiber? So, first one is this is called as attenuation to dispersion. Third one is the This is what I was referring. Fiber loss. Okay, so attenuation in the sense, okay. Here we are measuring the light signal. The measuring unit is measurement unit is dB. Okay, dB is equal to decibel. This is how we are measuring the power of the light. Got it? dB is the decibel value. Okay, so in attenuation, what will happen? See, for example, you have a 10-kilometer fiber. You send a light in 5 dB. Okay, but you received it 4.5 dB at the other end. So what is the loss here?
4.5 decibel loss.
0.5 dB loss is here.
Yeah.
So this loss, why it is happen is because of attenuation. Attenuation is what it means is, in general, nothing is ideal in this world. So whenever light travel in a fiber, for every kilometer, it loses 0.20 dB per kilometer.
Okay.
Okay,
So is it like dB means like no no
dB is the
I
decibel
didn't
measuring unit power. So here, how you like kilo, watt, liter, all those things
uh
we are telling. Similarly, it is the power level, measuring the power level, the unit of measuring the
so
light
measuring
signal,
the light
power,
means like
power,
power. Okay.
power. Yes,
Okay.
decibel. Okay, so what they are telling is, for if the people initially when fiber optic started, it was 30 dB per kilometer. Okay, then they slowly bring it down to 0.20. Even people are researching that they can even reach 0.011 dB per kilometer. The research is going on. But right now, all the fibers are in this range. So every fiber having these qualities is measured in terms of different ITU standard. For example, this one G655, G652, all those things. If it is a single mode fiber, the standard is different. Multi-mode is standard is different. I will give you the standard from 4 5 standards. You need to remember it. We don't have options because here in US, people are more concerned about rules. They always hang on the rules. So we should know the ITU definitions, numbers for these fiber characteristics. So I will give that. In India, people tend to forget it. But here we need to remember
Okay.
it. Okay, so this is called as fiber attenuation. Losing the power every kilometer, it is called as the attenuation. Why this is happening is because of the hydroxyl ions. In the glass medium, while manufacturing the fiber, there are some air particles or water particles or humidity is trapped inside the fiber. That is unavoidable situations. Okay, so that is why if you are looking at the glass, water glass, if you look at that, you can see a small bubble, small tiny particles inside in that. If you look at carefully, you can see that in a cheap glass materials, not in everyone. Since it is an unavoidable thing, this fiber is manufactured in a factory in a very tight environment, in a very clean and non-polluted environment. Still, we have some hydroxyl ions that eat the light source. That is the thing here. Okay, so what they are trying to do, the basic material in fiber is the silica material. So they try to mix it with the other what is that? Particles, iron, zinc silica, like that. They are making it and try to bring down the attenuation to a lowest level. So that is what happening here. Okay, dispersion, as I said that. the light travels like that. This is spreading of the pulse or spreading of the width of the light. So that is a dispersion. Or nothing is constant. Or I mean, everything has its limitation. Even if you use a laser light after traveling over a long distance, it started spreading with slowly spreading in. Okay.
Okay.
And the fiber loss, these losses are man-made losses. So mostly it is happening with the bending, micro bending and macro bending. So
Okay.
macro bending is like when we twist the fiber like this. If the bending ratio, this matters. If it is too sharp, there will be losses in the fiber. Or sometimes light will escape from the core and out of the fiber. So the bending of the fiber is very crucial here. Not like copper. Even if you bend it for 90-degree, copper will work, but fiber will not work. The first thing, it will break, otherwise it will you will get a degraded core, this one. So what will happen in the fiber manufacturing? The entire fiber cable, forget about core and cladding, the fiber is laid inside another pipe. I will show the photos. So here in light imperfections will be there inside it. So these are all called as the micro bending. And people used to coil the fiber inside a manhole, like coils. Those are all, if it is too tight, small circles, then that is called macro bending. And then another one is the Splice laws. Splice laws, splicing. What is splicing? So, for example, I want to run a fiber from one city to another city. The road length is 40 kilometer. Is it possible to manufacture one single fiber cable for 40 kilometers?
No, no.
So you need to prepare piece by piece. S- Correct. So after that, it will be one drum, another drum. So you need to join these two fibers, right? Will you agree that
Yeah.
Yes.
you need to connect the two fibers, couple it. So since both are glass, what we are doing is we are using like arc type heater. We heat both the fibers and melt it and join it. Because it's a glass, no, not like copper or something. Copper means what we are, if your length is not sufficient, what you are doing it in your cable, you do one coupler or an extension box, then you will stretch it for further. So here we have the luxury, since it is a glass, we can melt it and join it together. Simple logic. This is called as splicing. So there are splicing, fusion splicing is there. The most common use is fusion splicing. Here, even though you melt it and join it, there will be some losses. This loss is called splice loss. Splice losses. So, and the ITU recommended each splice loss should not be more than 0. dB per kilometer. Done. And then finally, connector loss. So fiber is connected to a connector. Then each wherever you terminate with the connector, there also you will lose some. The recommended value is 0.25 dB per dB per connector.
These are all losses.
Losses, yes. These are all the
Loss of light.
yes, loss of light.
Mm.
So, loss of light happened in three situations. One is
Okay.
attenuation, because of this is unavoidable during the manufacturing phase. Glass manufacturing the fiber, it captures the hydroxyl ions. Because of that, hydroxyl ions eat the light energy. So it is measured in dB per kilometer. Every kilometer, it loses zero point 0.2 dB, this one. And the next one is dispersion. Dispersion, the worst effect is we are not sending one light in modern optical communication. So in the dispersion, what is happening is we send multiple light sources. So because of that, what was happening is you are sending light like this, another light is sent like this. So they started talking to each other. We are sending multiple light sources. This is called as interference. So it is like in another way, scientific way, if you said that both waves are interfering with each other. Okay, that is a phenomenon. Okay. Fiber losses, micro bending, macro bending losses, splice losses, connector losses.
Okay.
In fiber loss, these all the losses.
Yes.
What is micro bending? Okay, so
Micro bending in the manufacturing itself, I will show that. In the cable, I showed it where it is that. See, the cable is yellow color. You saw that, no? Yellow color is like a jacket. I told single mode is in yellow,
yeah,
multiple fiber is in there. So that is a kind of
light
a
blue.
jacket. Inside a jacket, the fiber is, if you didn't properly insert manufacturing defects, it is.
Okay,
There will be a small bend and then goes in macro bending is like we made it like circles. You saw that we coiled the fiber or copper cable. Extra cable is there. The slack we used to coil it, right? So if it is too narrow, the radius is too sharp, then again it will start losing the fiber. Loss losses will happen.
okay.
Okay. So these are the basic physics in the fiber optics. I will show you now. If we go to training, that's one video we should do. Okay, slideshow. Okay, so this is the physical thing, Harish and Sai. You saw this is called as drum. You saw it in the US roads as well. So this kind of this is one fiber actually. Inside this fiber, we can say this is a fiber. Okay. This drum runs for 20 kilometer, 40 kilometers. They will return it whether this cable runs for 10 kilometer or 20 kilometer. So after that, you need to add more drums in this one.
Oh, so I didn't hear till now. After showing the picture, can you explain? I got some error with my earphones.
Okay. So this is actually the fiber cable, fiber drums looks like. I told you, no, the fiber is 10 meter, 10 kilometer length or 4 kilometer length, 20 kilometer length.
Yeah.
These are all the fiber is coiled in a drum and put it into the ground.
Okay.
This is actually the fiber looks like.
Upper one is cladding.
No, 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 no. I didn't come into core and cladding. In general overview, it looks like that. Even inside the fiber, you can't differentiate it. Very hard to differentiate what is core, what is cladding. I will show that. Don't worry. I will show that. So it
What is the top layer here?
top.
Protective layer.
A protective layer. We will come to that. We will. I'm just. This is the duct actually. This is like a PVC pipe, typical PVC pipe which we used in our water for carrying the water from water tank to our bathrooms. No? So this is inside this duct only. We are inserting the fiber. And we are laying it in the ground because why we are using it is someone is digging the ground tomorrow, it will protect the fiber from accidentally cut the fiber. So first they will lay the duct in under the ground. Then they will blow the fiber inside this duct. In India, you might have saw this one. In the roadside, you can see lot of green color pipe, yellow, green, red, orange color pipes in the roadside. Did you notice it?
Yeah.
Back in India. So that first they will just run a empty PVC pipe in the road and then they will blow the fiber out of it. No? So it looks like this. See, this is the duct, one big duct here. Inside, there are four smaller ducts are there. Each duct inside a duct, this is the actual fiber. So see how many fiber is there in this black cable? One, two, three, four, five, six. Six fibers are there. In the center, the white color is there. No, that is what is it? It is like thick plastic. It looks like another cable, but it is called a strengthening material. If this is not there, you will easily bend the cable and it will break because it is a glass. Will you agree that?
Yeah.
Okay. See here, you can see multiple cable. One, two, three, four, five, six, seven, eight cables are there. Here, six, eight. You can keep increasing it here. So this is the bigger view here. So this is called as duct. This is called as inner duct. This is the actual fiber. Inside the fiber, there are how many strands? Are called strands. Strand, strand. One. How many strand is there here? One, two, three, four, five, six, 7, 8, 9, 10, 11, 12 strands are there.
Okay.
Initially, when I was working, we started with 12. But nowadays, you won't believe it, in the same size, we sent 800 strands in this one. It means 800 fiber cables are sent in the are running here.
Okay.
So this is how we born. This setup already came. Initially, when we started the career, my career, we just draw one fiber inside one duct, and we extend one full fiber. Inside the fiber, there are actually
All
I say
strands.
fiber cable. We can say fiber cable. Inside the cable, you can see 12 fibers, 12 strands, fiber strands. We can say. So we blowed it. Is it possible for you to send another cable in this one?
Yeah.
Yes. But what
It,
is the challenge? Which one is easy? This setup or this setup?
the before setup.
This one.
Yeah.
Why? Because you gave a dedicated path. Here you need to squeeze it. Very tough to blow the fiber here. Because
Mm.
now in the same fiber, now in the same size, this is of same size only. But we have how many inner ducts are there? One, two, three, four, five, six, seven. Seven ducts are there. So it can carry seven cables, seven such cables happily inside.
Yeah.
So these are all modern developments. They're trying to, this is once you laid the duct, usually, where is the food? Usually, here, first thing they will do is they will lay the PVC pipes only. They will not lay the fiber. So they will put only the plastic fiber. Once they run the flagging, they couple it the same obvious distance. We couple it using it the PVC duct. Once it is done, people sit in one end and using a machine, blowing machine, they send the fiber inside it. I was looking for a picture of it. See, this is the color of multi-mode fiber. Blue. This is single mode. Ignore, this is a power cable. Don't think of it. Uh, this is the fiber cable. Okay. Single fiber strand.
That is mode, right?
Yes.
Multi-mode, right?
Multi-mode. This is multi-mode.
But singles. Okay, okay. Only one fiber cable
One
in.
fiber cable. Yes.
Okay. Understood.
Okay. Uh, okay. So we understood now this duct, inner duct and one, and then okay. These are all the different ways they send the fiber, manufacture the fiber because depends on the strength. Okay, so core is here, cladding is here. Outside it is a coating material, strengthening material. This strengthening fibers is nothing but it looks like this one. Uh, this is strengthening material. Okay, and the cable jacket. This is the yellow color is the cable jacket.
Oh.
And the coating is like it is made of plastic only. Usually, this modern things are coming like that. But here, look at this. They protected it, well protected. This is the one I was telling about. Plastic. This is actually fiber. This side it is a plastic. This side it is a plastic. So different. See this in one cable. How many strands are there? One, two, three, four. More than 12 are usually 12 will be there. Here also 12 will be there.
Mm-hmm.
These are all costly. Will you agree that fiber is actually cheap? But if you put all these things, well
Yeah,
protecting
it is.
it.
I believe. Yeah, it is. I accept.
So depends on the situation. Not everywhere we will go for it. If it is a rough environment, then see this is a fiber cable. Here they used to the metal. What is that? Metal கம்பிக்கு என்ன ஹரிஷ் இங்கிலீஷ்ல?
Metal,
Metal.
metal கம்பியா?
Ah,
அதான் iron rod and
that's
hanger.
it. Yeah, we used to hang our clothes in back in home in our terrace, right? We used to tie this metal rope kind of thing. Uh,
Yeah, GA.
Okay, G wire. Okay, uh, guide wire, right?
Yeah.
Okay, that is the one. See, these are all for specially for protector. I will show where it is now. That is used here in this kind of setup. See, here you are hanging the fiber. So if that is not used, then you will fiber will inside the fiber cable will break. So this is what I was talking about macro bending, the coiling. If you make it small circles, then it is gone.
I have a doubt here.
Yeah.
Can we, how it is rolled into that, like, it is a glass, right? Glass will break, right?
That is why we are using all this in a very good see, all the protective materials is there.
Oh, okay.
Uh,
Which is the most,
no, it is all if it is a safe environment, protecting is not required. For example, here in our case, data center environment, I will show the photo here. See here, nobody will walk in this rails. These are all called rails, right? Here, protection is
mm,
not required. Simply just put the cable on. It is one side only. Nobody is purposely going to break the cable. They just put the cable on top of it. So
Okay.
here also, this one and all, no protective material. Just if you fist your finger and kick it, it will break definitely. Um, here and all, no protection here because
Okay.
you will behave properly. We are expecting that. So that is the thing. See here,
Okay.
very delicate. If you break it or if you press it with your leg, then that's it gone. It will broke.
So after, like, I have a doubt. If,
Yes,
like,
sir.
think we are in a company,
Ah,
okay, they are using these fibers.
ah,
Like, if break one, the data will be not coming to the company.
yes. If it is
Okay.
broken, then that's it gone.
Oh, okay.
You need to replace the entire cable. You can't fix the existing cable. That's it. If this cable is gone, these cables are we can't able to splice it. It is costly. So, splicing machine itself cost millions of dollars. At least 2-3 million dollars that splicing because you are generating 2600 degrees Celsius in a
Okay.
compact mission. So even the splicing varnish itself is cleaned properly. I will show the photos like the splicing varnish totally different. It is very clean. AC is there inside. You pull the fiber inside the van and do the splicing.
Okay.
Okay.
The splicing is done when the fiber have to travel more distance.
Yes.
Okay.
See, I told you, no, 864 cable fibers are there now
Okay.
in the same fiber cable. This is cable. Duct is different. Inner duct, outer duct is there in the duct. Cable, fiber cable. Cable means inside there are multiple fiber. In this, you can say in this one cable, there are 865 fibers are there, or 865 fiber strand. We can say
Strand.
that strand.
Yeah.
Same. The people now mostly they follow this structure type only. What is that? This one. Core, cladding, coating, plastic coating, strengthening fiber material, and cable jacket. Everything is thick.
Okay.
Okay, these are all different packing of fibers. See, only two are there. Usually 12 are there. All those 12 fibers are differentiated using the color codes. So the color codes start with this one only. Usually they pack the fiber in ranges of 12. So it started with blue, unique colors. They gave unique colors, the color coding, same like our boys. Color coding, they follow it up for 12. Then for another batch, it will follow the I will show you the color coding. See, they covered 432 fibers using this color coding. So blue, one, blue, orange, blue, green, blue, brown. This side also same 12 colors. This side also same 12 colors. So using this matrix, they generated 432 color codes.
Why there is two whites?
White, two lines kind of thing. Because you need to cover up 800 fiber, no. So two lines will be there.
Okay.
Two white lines. Here one orange line, one white line. Orange line, one red line. One orange line, one yellow line. Like that. Color coding fiber. It is very difficult. This you can't remember it. We just hold it here now. Keep it as a reference now. Okay. Okay, these are all the connectors, different type of connectors. No? All the SC, APC, UPC, there is no logic in this one, best, worst, and all. Initially, so by looking at this, which one is cheaper? No?
LC, UPC.
LCAPC. Both are the same color, only different.
Okay.
Okay. So why it is costly? You are using metal protective. So
Metal.
this is
Yeah.
metal. So initially we started with this connector, then moved to this connector, and then finally we stick up with the LC and LC. But old systems still, this is completely wiped out. This is still there.
Okay.
So this is the same photo here. So you need to remember these words. SE means a little bit bulky. LC is slim, minimalistic design. FC is a screw type. ST is also a screw type. FC, ST, the screw is here. In FC, screw is in the panel side, in the equipment side. You got is the thread. You notice the thread? Here, for FC connector, the thread is in the equipment. For ST, the thread is inside the connector itself.
Okay.
And now people started in one connector. There are 8 fibers are there. See, 8 fibers are there. This kind of connectors is MPO, MTP connector. This is used in the modern data centers because between in AI world, from one GPU to another GPU, we are running 250 fibers. So laying that much fiber is difficult. Tracing is also difficult. So what we are using this 24 fiber connector MP4. One connector itself in the back, 24 fiber cables are there. So instead of 24 different connectors, now we are eliminating this kind of design. See, it looks very tedious. If you put your finger to remove one connector, then you will break another two connectors. This is very common in the data center environment, right? See, here 24 fibers or individual fibers are connected. Now it will be replaced with only one simple connector. Got it?
I got it.
So that,
Just 1 minute, sir.
yeah.
I'll be.
Shall we take 5-10 minutes break? Then we will continue QGAs now. Harish,
Okay. Okay for me. Yeah.
there were 5 minutes now.
Okay. Okay. Fine.
కొంచెం కొంచెం
சும்மா பொங்கல் வடை நான் சாப்பிடவும் இல்லை நான் சும்மா தான் வந்தேன் நான் சொல்லிட்டு இருக்கேன் வீடு அதான் இந்த அந்த நம்ம டிராவல் பக்கத்துல வாக்கிங் போவோம் டிராவல் பக்கத்துல அதான் அந்த சிக்னல்கிட்ட நான் கூட சொன்னேன்ல அந்த வீடு தாங்க நல்லா இருக்கணும் மொபைலாம் போவாங்க இங்க என்னால கற்பனை வச்சு தொலைக்கலாம் நம்ம எங்க வீட்ல இருந்து ஆட்டோ நிறைஞ்சு வரும் இதை தூக்கிடுவியா சும்மா இருந்தாங்க. இது அவன்கிட்ட நீ வெள்ளை கலர் கொடுத்திருக்கீங்க, அதான் அடிக்கிறாங்க. இப்ப வேணாம், அவன் ஃபங்க்ஷன் உண்மை அவள் தான் வந்து ஸ்ட்ராங்கா விஷயம்.
Okay. Harish, are you there? Harish, Sai.
Yes, bro. Can start actually. 20 minutes is there, so we can start.
Sai, are you there? Sai is not there.
Don't try to kill me, and you are.
I'm ready. We can start. Size coming in.
Okay. I'm waiting for Sai, sir. Harish.
Okay.
சிசருக்கு போட்டு
Function போறோமா போறோமா
அந்த காலையில டெய்லி சிரிப்போம்.
அந்த ஃபங்க்ஷன் போறோம்.
அது வந்து திரும்ப ட்ரெஸ்
Teacher. Hello, Sai.
போறியா? என்ன பயங்கர மேட்ச் பண்ணிட்டா வெளில போட்டா இங்க விளையாடுறதுக்கு அவ்வளவு மேக்கப் இல்ல அவுட் சைட் போறியா? இங்க வா இங்க வா இங்க வா
அந்த மாதிரி செமையா இருக்கு. இங்க வா. எங்க போற? அப்படியே இருக்கணும்.
அது ஏதோ மாத்துறதா
செமையா இருக்கு. அப்படியே விஜய் மாதிரியே இருக்கு. போகணும். What's big stuff?
That's very important. Simple, familiar, familiar.
Hi, Surendra. Yeah, I'm
Ah,
back.
okay.
Yeah, sorry, sorry.
No worries.
Yeah.
Okay. So this one is called the fiber patch panel. So all the fibers
Your
come.
screen.
Oh, okay.
Yeah.
Okay. It looks like it is the fiber patch panel. So all the fibers, once entered the building, we need to terminate in the connectors. The fiber comes to this one. This box is called fiber distribution panel. Fiber distribution panel. So for example, here 12 fibers are there. This box is ready-made, readily available. It is all connected. Here, other end is open. So whatever fiber is coming from the ground, it is kind of spliced to all the 12 fibers. So that way we can use it in the data center environment.
Okay.
Okay, so this is the fusion splicing, which I told you, no? So this is one fiber, this is another fiber. This is using the arc that this produces the heat. It melts the fiber and join the two fibers. So it will align properly. Here the trick is you need to align the fiber so that core will stick to core, clad will stick to the cladding surface. No? So that is a real challenge. You can see everything here in the display board now. All the modern splicing machines comes whether it is properly merging or if there is an alignment or something, misalignment is there or not. So it's a sophisticated splicing machines now. So it's very costly. Okay, that's another inside view. See, this is the actual fiber. It looks like our hair. It looks like our hair only. That is so much thin, very thin. I told you, no, the diameter of the core is 2.5 micron.
6.5.
6 point. Okay, yeah, 6.5. Yes. So imagine then the size of it. No.
6.5
A meter.
micrometer. Okay.
That's for the single lane. Yeah.
Very, very thin actually.
In that, the data is transferring.
Yes. I will give one amazing thing is in one single fiber cable in this fiber strand, even the entire planet is talking over phone. It still was occupied by 30% only.
Oh,
So it has theoretically the fiber has a infinite bandwidth, but the only limitation is the electronics because both sides, I told you, we need to convert the optical signal to electrical signal.
electrical signal.
Conversion is matters, modulation is matters. Everything, all the other people have a limitation. Because of that, they couldn't able to exploit the full potential of the fiber.
Okay.
They started with 10, 100, 400 gigabit, 800 gigabit. Now in one fiber, they can push 1 terabyte.
In one single fiber.
One single fiber.
Okay.
Yeah. I still remember in my days we send every fiber cable have 48 fibers. Out of that 48 fibers, only two fibers were used for Reliance till 2016 or 17. No, 2012. Sorry, 2012. So 10 years when India has a mobile communication, we still survived with only two fibers across the nation.
Okay.
Now, after that 4G, everything comes bandwidth
Two
heavy.
fibers. Two fibers means, is this the
One,
fiber?
yes, two pair. So actually, if I say fiber means for communication, we need one pair. One is for transmission. One is for reception.
Pad? What is
Pair. Like your,
pair? Okay.
pair. Yeah, like your chapels, it's
Oh
always
yeah,
one
yeah,
pair.
pair. Yeah,
Yeah.
yeah.
One is for transmission, one is for reception. one cable.
Okay. So one cable is what you're showing in the picture is called
Yes,
one cable.
it's one cable, one fiber strand, we can say.
Okay, one fiber strand. Okay. Oh,
This is mechanical splicing. So we are not doing heating up all those things. It is a temporary arrangement. So just we keep the inside and lock it. That's it.
okay.
This is for temporary cases. For example, as I told you, in data center, if you broke
Okay.
accidentally one fiber, then just connect it temporarily until you replace the cable.
So
Okay.
one doubt is that the splicing, the two wires are connected inside. So that's
Right.
the reason why we are using this splicing, right?
Right. Yeah.
Connected, yeah, right. Yeah.
To join two fibers.
To join two fibers, yeah. Okay, got it.
Okay, so this is another deployment scenarios. We can put it in underground as well as in the aerial also. You can see this scenario in US in a lot of places. So this is called as a slack cable. So in future they because of road issues or some issues, they move the pole from here to another place. So in that case, we should be ready to pull the fiber also. That is why they keep a slack everywhere in every turn, every pole they put a slack, and then they run the fiber.
Okay.
Future maintenance purpose. No?
Okay.
This is the splice box. You joined two fiber cables here. That is sealed and kept it in one splice box. Splice box. No. This is called as. No.
Okay.
Okay. So it is a traditional duct is there. These are all the couplers. As I
That is
told you,
ducta.
duct. This is duct.
You show me the big ducts, right?
Once you laid it, it looks like this in the ground.
Oh, okay.
Yeah, I will show you. Uh, See the blow like that. So this coil they will lay like this, like this. Stretch the coil.
Okay, okay. I got it. I got it.
See, this is blowing. The duct is there. Inside, these are all very old technique. Before here in US, they blow the fiber. What happened in India? We insert a thread, we tie the cable at the other end, we pull it in this direction.
Okay.
So this is another way. See, they cut the road. In India, you can see that in the lines. Just bury only one duct here and then blow the fiber here. Instead of trenching, like doing this, sorry, doing that, this one, this is a simple way. But you
Okay.
can't run multiple bunch of fibers here like this.
Only one.
Yeah.
Okay.
This setup only we are going to work on in the fiber FTTH scenario. So it will look like this. So they see the drum, they'll run the fiber like this, blow the fiber.
Is it a fiber or
No,
a...
duct, sorry, duct.
Okay. Yeah. Okay. Okay. Okay.
This is road cutting. In the another duct, inner duct.
Mm.
It will be transported like this.
Okay.
This is the best idea. In US, they made like this. Under the road, the fiber is there. So before constructing any road in US, that is a good practice. They first to do the what is that? The drainage water, drainage rainwater separate. and the sewage water pipe, and then they install the fiber pipe, gas pipe, everything they put it, and then they laid the road.
Okay.
Actually, this is the no, this is not. Okay, so I told you slack. This is slack we called it. There is a rule wherever you are turning or bending, you coiled it in the corner. So this is a duct. This is a fiber cable. Just to create a fiber slack here. Here,
Okay.
the same fiber cable. It is spliced here and slacked here. Here, a duct also comes inside the manhole. These are all called manholes. This is a handhold. If you can able to put your hand, then it is handhold. If you can enter into the hole, then it is called as manhole.
Okay.
So once it reaches the data center, we have a tray. The cable will, in the initial days, we lay the cable under the floor. But now we change the approach because tracing those cables under the tray is very difficult. Now under the floor is very difficult. So it is all false floor only. But now they come up with this approach. This is a novel design. So they will follow only the defined path only. But underground earlier, if you open the false ceiling in US, the wires are going haywire left and right. Now. There is no defined path. So that is why earlier the data centers were like that. When I worked like that, I need to open all the tails here and route the cable from one cabinet to another cabinet. Now it is rack mounted. Now. All the trays, fiber trays. So it is
Okay.
in the back side. So the typical, this is the fiber distribution panel, which I showed it in the first box. So this is some 48 fibers are there, 48 fibers are there. Now all these are replaced by the MPO connector. So 21 for 12 fibers, only one connector will be there. Just one. It saves the space. This is power cables. Okay,
Okay.
that's it. Okay, then shall we jump on to QGIS? So this is basic. We will see the optical budgets from the after seeing the networking class now.
Okay. I think I have to leave Surendran at
Oh,
4.
okay. Oh, 356. Okay, I'm sorry.
4 minutes is there. So yeah, I think this is really good actually. These images are really good
Uh,
actually to understand.
uh, it is there. Harish, I will fix the whiteboard.
Yeah, no
Um,
problem. Yeah, take time. Yeah, no problem.
Sai, if you go to visuals to guide, those
Okay.
PPTs are here.
Okay. The PPT what you told.
Yes, yes. And another one, this is, I want to show that just 2 minutes.
Yeah. Sure. That's fine.
Uh, how to check the fiber here. See, if you see it in a microscope, then only you can see the core. This is the core area. This is the cladding area. In naked eye, you can't able to see that.
Okay.
Okay. See, this is how you can see the fiber. This is a video scope now it is called as. See, this is a fiber cable. You just connect with the video camera. Now it is they are modern techniques are there compared to 10, 20 years when I booked. I used this kind of one. It was very bulky. It is very sleek here. Now, if even a pen drive, this is a camera. You just connect the fiber to this knob and then you can see the results in the uh, in the laptop screen.
Mm.
Okay, so I want to show that this is a small part of core, black surrounding cladding. This is the plastic material, protecting the plastic material outer. Okay, see, if you look at the fiber, these are all the dust, small dust. If you have a dust here, that is not a problem. If you have a dust here, it will hit your fiber optic light, because if there is a small dust or something, or a water particle, then the light started deviating.
Oh,
So you need to see this, and the device, the fiber video scope, it should show that it is pass. Otherwise, it will not. It split the area into 4 zones. The first zone, the blue color, core area and cladding area, and then the outer area. Zone D is the bigger area.
okay.
Okay, see some of the dust in the fiber. These liquids, what happened? We clean the fiber before connecting it. So what we use is isopropyl alcohol. If we didn't, within a second, it will evaporate. But if it is not evaporating, then it looks like this. See, these are all damaged one. Scratches, you can see is a lot of scratches are there now. If you 10
Okay.
times plug it out, then scratches will happen. All
Okay.
this will deviate the fiber. See, this is another dust, bad connector. It will simply eat 10 dB power. These scenarios.
Oh,
This is oil particles. Core is inside, the white one, cladding is outside. So this is how we clean the fiber. So isopropyl alcohol solution, just put it in a tissue paper and then rub the fiber. Every time we used to do it.
okay.
If you put if so much liquid is there, then this situation will happen.
Uh-huh.
Another way to clean the fiber. Now readily US wipes are there. We can just like that wipe it. Special wipes.
Okay.
Alcohol wipes. So the major part is safety, fiber optics. If you are going for a certification, safety is why safety is important is you saw that fiber, like it is a very small thin hair, like if it is broken, there are pieces are there. It won't, you can't see that pieces in the floor. It is virtually impossible to see the floor. So it might be sticking in your hand. You didn't know that by accidentally, if you swallow those things, that is a very worst case scenarios. It may hit your eyes, nose, it get inside your body. That is a very dangerous thing. And isopropyl alcohol, that is also a dangerous thing. And the third one is, people always say that laser light will hit your the area, but the laser power is very, very minimum. It will not bother you. It will not harm you. The real danger is the fiber, the glass particles. There is a high chance that it get inside your body.
Yeah.
And make wounds. It creates scratches in your hand. So these are all the cases now.
Okay.
So fiber video scope. This is to check the fiber at the connector end.
Mm-hmm.
Okay, done. So tomorrow we will continue or no, we will continue the optical power budget and the QGAS. That's a formula only. So then we will move on to networking. We will complete one chapter full.
Okay.
Sure. Yeah.
Uh,
Tomorrow, what time, sir?
Same, we'll target 3:30. Or
3:30 to 5, yeah, I'm fine.
yeah, yeah.
Okay.
Was
Harish, are you?
Yeah.
4 o'clock.
Yeah. Fine. Fine. Yeah. Fine.
Okay.
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 Okay. And we'll see you tomorrow.
Bye.
Bye. Bye. Yeah.
Mm.